Let's have a look at one more question here. This is a little bit different, but similar in some sense as well, that we have an angle in here. It says a 20-kilogram wagon is being pulled to the right with a force of 100 newtons, angle 30 degrees above the horizontal. There's a 50-newton force of friction acting on the wagon. We want to find the acceleration of the wagon. Guess not. All right. So we got this wagon here. It's 20 kilograms. What's going on here? We're pulling it with a force of 100 newtons at an angle of 30 degrees above the horizontal. It doesn't say whether it's left or right, but we'll make it to the right here. Call that FA is 100 newtons, and it's 30 degrees above the horizontal. There is a 50 newton force of friction acting. Can anybody tell me which way friction acts here? Yeah, go on. Yeah, it's going to act to the left. If we're pulling it to the right, then friction's going to act to the left, right? So let's make that over here. Any other forces here? Yeah, there's something. What else is acting here? Come on, you know this. You might have a little bit of trouble with what their values are in this question, but we know which two forces are acting here. Yeah, Erica? Okay, force of gravity is acting down, and, oh, JC, that's what you said, isn't it? Just kind of register now. Force of gravity is acting down, the normal force is acting up. Normal force equal to the force of gravity? Like this? No, it isn't. The force of gravity is smaller than the normal force here. Can anybody tell me why gravity is smaller than the normal force? Sorry, normal force is smaller than gravity here. Yep, Ariel? Yeah, we're pulling up at 100 newtons. So the normal force, well, the upward force has to balance the downward force. But the upward force is helped along by the y component of the applied force, of FA. So what we're really saying here is this. FA has an x component to it. We'll call it Fx. And it also has a y component. We're going to say that the force of gravity acting down is, the magnitude of gravity acting down, that is equal to the normal force plus the y component of the applied force acting up. Does that make sense? Right? The total downward force, which is this, is equal to the total upward force, which is this. Usually, gravity equals the normal force because gravity is the total downward and the normal force is the total upward. But that's not the case here. Normal force is being helped along. All right. Now, as it turns out, I don't think we're going to need to use that for this particular question. But if you were given a coefficient of friction here instead of a force, then you would need to know what the normal force was so that you could multiply mu times that value. In this question, I think all we're going to have to do is say F net is equal to what? Look, this cancels with this and this. So what are we left with? F net is equal to what? Maddie, F net is equal to what? What am I left with after I start crossing things off that cancel? The force of friction. Christian, anything else there that we haven't canceled? Yeah, good. The x component of that applied force. Listen, we don't care about the y component because that's not contributing to the motion, right? We care about the x component. Now, we'd say m times a is the net force is equal to ff plus fx. By the way, do we know how to find fx? We got a funny angle, right? Take it off to the side and get rid of it. You can find fx, right? Cosine 30 degrees is equal to x over 100. Solve for the value of fx. Sub it in here, make it positive. ff is negative 50. M is 20. Solve for the acceleration, right? Is it a hard question? No, once you see it done, right? Okay, in the end, that 100 newtons is important. But really, what's really important about it? Well, it's the component that pulls it, that actually causes motion. The y component doesn't cause any motion. It combines with the normal force to cancel gravity. But the x component does cause motion. The x component, by the way, would be 86.6 newtons using the cosine function. So we'd say 20 times a equals negative 50 plus 86.6. We're going to say 20 is equal to 36. 36 divided by 20, I believe, works out to be 1.8 meters per second squared. Okay, if I used 150, the acceleration would be, I don't know, bigger than whatever. I'm not sure what it would be, but bigger than 1.8, right? But we're not using that entire 100 to cause the motion, right? Think about it. You pull a wagon like this, right? You pull a wagon like this. If you pulled it like this, that's more effective, right? Because all of your force then is going into the motion. All right, let's work on that bonus question or that special question for tonight, and we'll pick this up here tomorrow, right?